Hello everybody. Tonight's flipped homework is page 35 of our workbooks, and the title is The Why Behind Real-World Domain and Range Restrictions. So we've had a lot of class conversations about this and have talked about it through the practice, but let's have a nice summary set of notes as to why restrictions exist. Just in case you were not in class today, I am actually going to include, if we go back to page 32, number 2. It was in the agenda as our in-class debrief, and it was a very important question that we went over as a class. So just in case you were not in class today, I do want to include this in the video for tonight. If you were in class and you do have this set of notes, feel free to fast forward the video to page 35. For those of us that do need page 32, let's look at this question. At 2.4 calories burned per pound of weight each hour, the calories C, so I'm going to underline that, define a variable for me, burned H hours I'm trying to get these straight lines. H hours by a 110-pound person walking briskly can be modeled by, and check it out, gave me a model, so I'm going to highlight it. C of H equals 110 times 2.4H. Notice it gives us a space here. It says, or C of H equals. So it's asking us, is there something we can do here? Well, when I take a step back and I look at this model, I see that I can actually do 110 times 2.4. So let's do that, 110 times 2.4. And if you didn't get your calculator out yet, go ahead and press pause, go get it, so that you can do the math with us. When I do 110 times 2.4, I get 264. And then H is still there. So our model has now become a little more simplified. C of H equals 264H. Part A asks us to define our variables. Well, because we did a fantastic job of underlining when we were reading for information, I see that H is going to be number of hours, and C, or C of H, the output, these mean the same thing, is going to be the number of calories. Part B says, how is this real-world scenario different when it comes to thinking about how to determine domain and range? So there's got to be something different about this one compared to the ones we've done so far. Now we have a sense for how domain and range works in the real world. Our practice is, once we've defined our variables, we know that domain is X and range is Y. But we now know to say that domain is not just about X values. X here is hours, so I'm going to put hours above the word domain, and I'm going to put calories above the word range. And then typically I would say, okay, well, I know that domain is about time, hours, range is about calories. Let me go back and reread and find a restriction about the number of hours this person or a person is exercising, or about calories. When I reread, I don't see anything here about a limit on time or calories. I mean, I have this information, it's a fact. This is a fact that 2.4 calories is burned per pound. That's a fact that actually becomes part of my equation. That's not a restriction. And then here, it's a 110-pound person. Again, another fact. That's not a restriction on time, and it's not a restriction on calories. So that's what catches our attention. So how is this scenario different? No given restriction on the number of hours or the number of calories. So we are not given a restriction. That's what makes this scenario different. But not to fear, we are working in the real world. The real world has restrictions. And let's really think about what that means. So in our scenario here, we're talking about time and calories, hours and calories. Think about the number line, right? So if I drew myself a number line, here's 0, 1, 2, and so on, and then -1, -2. If I'm thinking about values that I can have for hours and calories, is this entire number line open to you? I can have 1 hour, I can have 2 hours. Can I have -1 hours or -2 hours? No, we can't. We can't have negative time. So I have a real world restriction here. Oh, I should use H for hours. That I cannot have negative time. So the smallest possible value for time is no time, which is 0. And then I get my middle setup here going. I can have 0 hours, so I'm going to put a line underneath. And then, in theory, we can consider any other possible number greater than 0. So that's going to be 0 to positive infinity. Then let's think about calories. I can have 1 calorie, 2 calories, 3 calories, 4, 5, 6, 7 calories. I can have 0 calories, that's okay. But can I have -1 calories or -2 calories? No, not possible. So, in similar fashion, when we're talking about a restriction on our range, on C of H, the smallest possible number of calories in the real world is 0 calories. I can have 0 calories. And then in theory, we can talk about hundreds of calories, thousands of calories. So really, it'll go forever. I mean, no one really talks about 1,000,000 calories, but technically 1,000,000 calories could exist. So 0 to infinity. So the big learning moment for number 2 here is that if no restriction is given, think about the real world restriction. Then we're asked to graph. So in last night's video, we talked about how we can use the domain and range to set up some ordered pairs. So my domain is 0 to infinity. My range is 0 to infinity. Smallest x is connected to my smallest y, so 0, 0. But we definitely can't consider negative infinity, infinity, comma, infinity as an ordered pair. So we do have a little bit of algebra to do here. It really just depends on what you want to count by. And so I'm going to actually hold myself back from committing to ordered pairs. Let me show you what I mean. So getting some labels on the graph first. I've got number of hours here and number of calories. So you really have dozens and dozens of choices. Maybe you say you want to plug in 10 and 20. Make sure you have a scale that can account for 10 and 20. So maybe I choose to count by tens and I choose 10 and 20. Maybe I choose to count by 50. So I choose to plug in 50 and 100. Or maybe I choose to count by 100 and I plug in 100 and 200. You get to pick 2 other x values. So I'm not even going to leave those 2. I'm going to just leave a note. Choose 2 values to plug in for x to calculate y. And those will get you the ordered pairs you need. Remember, you're plugging into the function you were given here at the top. C of h equals 264h. So I'm just going to leave that right here for you. C of h equals 264h. So then you're going to have C of some number that you're plugging in, get your answer, and then C of some other number you're plugging in, get your answer. Ordered pairs, graph, bada bing, bada boom, and you are done with the graph. I will also leave E to you. So D and E are for you to do. Use the graph to estimate how long it would take to burn 400 calories. And again, if you were there in class today for the debrief, fantastic. We already did D and E together. If you are watching it on the video, also fantastic. Please check in with me about your graph and how you answered this follow-up question. All right. Let's get over to the debrief for the flipped notes for tonight, page 35. So go to page 35. The title is The Why Behind Real-World Domain and Range Restrictions. And again, I acknowledge that we have had verbal conversations about this, but it's very good for us now to take a moment and really make this concrete. Why do these exist? It says the domain and range of algebraic functions are usually assumed to be the set of all real numbers, which would mean negative infinity to infinity. That's what we mean by that. Like any value you want. In some cases, though, the domain or range of a function may be a subset of the real numbers because, we should highlight this, certain numbers would not make sense in a real-life problem or situation. And we're going to explore what that means by looking at two real-world scenarios for today's notes. Number one, the height of a projectile launched upward at a speed of 32 feet per second from a height of 128 feet is given by this function. So as soon as I see that I'm given a function, we're going to highlight it. The sketch below shows the values for x that make sense in real life. All right, before we look at these follow-up questions, let's define our variables. I've got t, so this should say t. I've got t and h of t. I didn't see any italic t's or h of t's here, so we have to reason, what are the two measurable things happening? So I see height, and then I see this label feet per second. So feet is how height is being measured, and I've got time in seconds. Where do you think seconds is going to go, and where do you think feet is going to go for the variables? I'm hoping that we do one of two things. Either remember from science that time is almost always our independent variable. So I'm going to put time, and it's measured in seconds. Or second, you maybe thought that t for time, in some real world problems that helps out to remember that. Typically, if t is involved and time is involved, almost always they're saying t is time. The stronger line of reasoning would be to remember that if time is present in a real world scenario, that's always our independent variable. So t is time in seconds, h of t is the resulting height of the object measured in feet. We can add those labels to our graph, time in seconds, and height in feet. Let's see if we can now reason on the answer to these two questions. Why do the negative values of x, here on the x-axis, I'm going to change x to t, not make sense? So my values for t are on the x-axis. If I were to extend this over to get some negative values, this is -1, -2, can we have negative time? Nope, we cannot. No negative time. So t is time. in seconds. Can't have negative time. So we have a restriction on that domain because we cannot have negative time. Now let's think about the second question. Why do the negative values of y not make sense? You can either leave that as a y, or our notation for the y-axis or the y values is h of t. Well, let's see. Let's add to this axis. Let's go down a little bit. This would be, this is counting by 20, so negative 20, negative 40, if I was extending the y-axis down. These y values represent height. Can we have negative height? This is actually an interesting question. There is a scenario where you could argue that height could be negative. So I'll be interested to see what ideas you guys come in with tomorrow. When can height be negative? Let's consider for this object, this object that's flying through the air. In this instance, we cannot have negative height because it's getting launched from the top of a building, right? And it falls, it's starting to get launched and it starts to fall. That object is done traveling when it hit the ground. So h of t is the height in feet here. The object stops traveling when it hit the ground. Which is 0. Very good. On your own, so I'll leave this because it's part of our conversation. Please work on the domain and range by yourself. So I'm actually going to pause my video and I'm actually going to fill this all out, this section right here, and we will compare answers when you're ready. So right now, see, look, I'm going to pull up my little recorder. I'm pressing pause. Please press pause yourself and only press play when you have gotten the domain and range and set and interval notation by yourself, and then we will compare. Be right back with you in just a couple seconds. Press pause. How did we do? Do we match? I hope so, or I hope we're close. So let me get my pencil on here real quick. If yours and mine matches, feel free to fast forward a little bit to number 2. If we don't match, let's see what happened. So when I come in from the left for the domain, I stop when I hit the graph, and I ask myself, where am I on the x-axis? I'm going to get rid of my red writing just in case that gets in your way of seeing it. On the x-axis, I'm at 0, so that's where this 0 came from. Then I'm going to come in from the right side, so coming in from the right, I stop when I hit the graph, ask myself, where am I on the x-axis? I am at 4, so that's where 4 came from. So t, our time, is between 0 and 4 seconds. Then to get my range, I turn my pencil like so, and I'm going to now come in from the bottom. I stop when I hit the graph, and I hit the graph right here. So then I come over and I ask myself, where am I on the y-axis? I am at 0. That is where 0 came from for our range. And then we're going to come in from the top. So I bring my pencil to the top of the graph, and I stop when I hit the graph. I hit the graph right here, but I'm asking myself, how am I going to figure out where that is? So this is the top. I'm just going to make a little red mark so I can move the pencil out of the way. It's very helpful to me that I'm actually given that ordered pair right at the top. Remember that our range is all about our y values, or in this case our h of t values here on the y-axis. So that makes this right here highest point, which automatically means largest y value. So that's how I knew 144 here for the range. Awesome. Let's get to our last example for tonight's notes, which is number 2. It's all about shoes. So the number of shoes in x pairs of shoes, so let's underline that. I see it gave me a variable right there, can be expressed by the function f of x equals 2x. I see that it gives me a model. I'm going to highlight that. The subset of the real numbers makes, what subset of the real numbers makes sense for this domain? So when we say subset, we're saying like what piece of all possible x values, what restriction is going to exist? Well, the domain is about what? Well, I see here I underlined x is the pairs of shoes. Domain is all about x. So maybe to help us think about this, I'm going to circle domain, and I'm going to write myself a little note that domain is all about number of pairs of shoes. I can have 0 pairs of shoes. I can have 1 pair of shoes, 2 pairs of shoes, 3 pairs of shoes. Can you have 3.5 pairs of shoes? See, technically, I guess that would mean you lost a sneaker. I'm not really sure you would wear 1 shoe and a sock. So for real world purposes, we are going to reason that we cannot have half pairs of shoes. So it's going to go 0, 1, 2, 3, 4, and going to keep going. And then we're asked, what subset would make sense for the range of the function? Well, what's the range about? I only underlined x pairs of shoes, but if I look at this entire statement, it says the number of shoes in x pairs can be expressed by this. So this is actually what y is about, the total number of shoes. Total So let's figure this out. If I have 0 pairs of shoes, I have 0 shoes. If you have 1 pair of shoes, how many shoes is that? This is 1 pair of shoes. That's 2 shoes. So that's 2. 2 pairs of shoes is 4 shoes. 3 pairs of shoes, 6. 4 pairs of shoes, 8. The directions say create a table that models you owning 4 pairs of shoes, then graph. So let's see. We can have 0, 0. That's no pairs. 1. If I have 1 pair of shoes, that's 2, total number. 3 pairs of shoes, 2 pairs of shoes is 4 shoes. 3 pairs of shoes, 6. And then I'm going to add a box because we were told to get down to 4 pairs of shoes, which makes 8 total number of shoes. So just to make sure we're all on the same page, between this shelf right here is 4 pairs of shoes. So that would be 1, 2, 3, 4, 5, 6, 7, 8. 8 shoes total. And let's plot these points. So I've got 0, 0, 1, 2, come back to 0, 0. To graph 2, 4, I'm going to go right 2 up 1, 2, 3, 4, 3, 6, back to 0, 0, and finally to graph 4, 8, 1, 2, 3, 4 to the right, up 8. Let's get some labels. So this is number of pairs of shoes, and this is total number of shoes. The question I'm asking here is, why does it make sense to have points and whole numbers? Whole numbers meaning we have no decimals, we have no fractions, instead of a continuous line. And if you have an idea, I would like you to pause and jot your answer down. So what this question is saying is, we are not going to be creating a line. We are not doing that. It's staying ordered pairs. And the question is, why? You cannot have decimal number of shoes. So for example, can't have 3.78 pairs of shoes. It just doesn't exist in the real world. So here we have a restriction. Not only are we not going to have negatives, but we're going to have a list. So if I asked you for your domain on this, my domain, I would be listing 0, 1, 2, 3. And for my range, I would also have a list. 0, 2, 4, 6, and so on. Because we have no continuity here. This is discrete. These are countable points. Very nice. I'm really happy we had a chance to get the big picture on our domain restrictions. To recap for the one at the top, we have restrictions because we cannot have negative time, and in this scenario, we do not have negative height. Remember, I have a challenge question to you to think about: in what special circumstances would negative height exist? It does happen sometimes, but most of the time, no. And then restrictions existed here in this question about the shoes, because not only can you not have negative shoes, but we have ordered pairs, because you can't have decimal shoes. Very good. Any questions? I look forward to hearing about those thoughts and questions in the debrief tomorrow. Have a great night, everybody.